In this video, we will see the different types of lasers. We will learn about ruby laser and a helium neon laser. Lasers are divided into different types based on the material used. Some of the important types of lasers are solid-state laser, example is ruby laser, Nd:YAG laser, etc. Gas lasers, example helium neon laser, carbon dioxide laser, etc. Semiconductor diode lasers, for example gas arsenic laser, INP laser. Most lasers emit light in red or IR regions, infrared regions. Lasers work in two modes, that is continuous mode or in a pulse mode. Now let us see the ruby laser. A ruby laser is a solid-state laser. A ruby laser is an aluminum dioxide crystal containing of about 0.05% of chromium atoms, that is Cr3 plus ions, as chromium atoms, and 3 plus chromium 3 plus ions are active centers, whereas aluminum and oxygen are inert atoms. Let us see the construction. The crystal ruby rod of about 4 cm in length and 1 cm in diameter is taken. You can see it here in the diagram. Its ends are grounded and polished. The end faces are exactly parallel. You can see them exactly parallel and perpendicular to the optical axis. The end faces of the ruby rod are silvered to form the optical resonator. Here, this face, that is the rear face, is totally reflecting, whereas the front face is partially reflecting, through which the laser beam comes out. Now, the laser rod is surrounded by helical photographic flash lamp, which is filled with xenon. When activated by the power supply, the xenon lamp flashes white light. See the working. The pumping mechanism. When a xenon flash lamp is switched on, the discharge generates intense bursts of white light, lasting for few milliseconds. The chromium 3 plus ions are excited to E3 and E3- by green and blue components of white light. You can see it here, the chromium ions here, after absorbing the blue light, get excited to E3, and the chromium ions which absorb the green light get excited to E3-. So this E3 and E3- are the excited levels. They do not remain here. The excited ions do not remain here for longer time. And after about 10⁻⁻8 seconds, immediately they make a spontaneous transition to E2. So E2 is a metastable state and it is a non-radiative transition. Now in E2, the atoms, chromium ions, which are the active centers, they keep on accumulating here till it produces an inversion population between E2 and E1. So the number of the atoms in E2 must be very much higher, more than half than E1. Now once the inversion population is set up, a chance photon, that is a photon which is emitted spontaneously from E2, from the metastable state E2, can trigger the chromium ions here to produce more stimulated emissions. These stimulated emissions, they travel back and forth in the They travel back and forth between the mirrors until a stable strong stable output of frequency of wavelength 6943 of red color emerges out. Okay, and the chrome emerges out. The salient features. Now, the salient features of ruby rod laser is it uses 3-level pumping scheme. You can see here 3-level pumping scheme, E1, E2 and E3, both this. Okay. Now, active centers are chromium 3 plus ions, and the light from the xenon and krypton flash lamp is a pumping agent. The low efficiency, it produces low efficiency and moderate power output. It operates in continuous wave mode or in a pulse mode. Now let us see the second type of a laser, that is the helium neon laser. The construction. Now, helium neon laser is made up of a long discharge tube. You can see a long discharge tube, which is filled with a mixture of helium and neon gases in the ratio of 10:1. Now, in this case, the neon atoms are the active centers, whereas the helium atoms, they help the neon atoms to get excited. Now, these neon atoms are active centers and have energy levels suitable for laser transition. Electrodes here, you can see here, anode and cathode. These are the electrodes. They produce the discharge in the gas. You can see it in the diagram that the tubes are sealed by the inclined windows, and the two mirrors which are arranged to form the optical resonator. One mirror, that is the rear mirror, is 100% reflecting, whereas the front mirror is partially reflecting, through which a red beam of laser light about 6.3 to 8 Armstrong wavelength emerges out. Now let us see the working of the helium neon laser. Now, the high voltage, about 10 kilovolt, is applied across the gas mixture to ionize the gases. So the electrons and the ions produced collide with the helium and the neon atoms all along the way. The energetic electrons excite the helium atoms to the excited levels of helium, now which is at 20.61 electron volt above the ground level. It is a metastable level, but the excited helium atoms cannot return to the ground state through spontaneous emission. However, the excited helium atom can return to the ground state by transferring excess of energy to the neon atom through collision. So we can see here in the diagram, this is the metastable state of helium, whereas this is the neon atoms. Okay. Now this is the ground state. Okay. So now it cannot come back to its ground state helium unless it gives energy to the neon atoms by collision. In this way, the helium atoms, they help the neon atoms to get excited. Now we can see here in the diagram, we can see here the energy, the excited level of helium atom is 20.61 electron volt above the ground level. However, neon energy level is E5 is at 20.66 electron volt. Now this and this is close by, okay, which is close by to the excited level of F2, excited level F2 of helium atom. Therefore, there is resonance. since they are almost equal, 20.61 and 20.66, they are almost equal, so there is resonance. However, the difference between them is 0.05 electron volt. Therefore, the resonant transfer of energy between the excited helium atom and the ground level of the neon atom, the kinetic energy of the helium atom provide the additional 0.5 electron volt. This is very important. The kinetic energy of the helium atom provide the additional 0.5 electron volt required for the excitation of the helium atom. The difference between them was 0.05. So that is provided by the kinetic energy of the helium atom. Then once they excite the neon atoms, the helium atom drops back to the ground state. This is called pumping mechanism in helium neon laser. Now let us see the population inversion. The upper state, you can see here, the upper state of the helium neon laser is a metastable state. So the neon atoms keep on accumulating here. Okay, and until there is a population inversion between E5 and E3. Then the chance photon, that is a photon which is emitted spontaneously from neon from metastable state to E3, okay, triggers more excited atoms to produce stimulated emission of red color, that is of 60 to 8. Now this photons of red color emitted spontaneously by few atoms in the energy level E5, okay, E5, the spontaneous they travel through the gas mixture back and forth. Okay, they travel along the optical cavity until a stable laser beam emerges out from the partially transmitting mirror. In this way, the transition E5 and E3 generates a laser beam of wavelength 6328 Armstrong. Now, from here, from E3, the neon atoms, they drop to E2 spontaneously. And again, E2 becomes a metastable state. So the neon atoms accumulate at E2 level. However, the atoms which are there in the E2 level, that is the neon atoms, they return to the ground state by frequent collisions with the walls of the tube. In this way, the neon atoms are once again available for excitation in the helium-neon gas mixture. And once again available in the excitation to the higher state and participate in the lasing action. This maintains the continuous lasing emission and the laser operates in the continuous mode. Okay. Now, in this, the salient features. It uses 4-level pumping scheme. Active centers are neon atoms. The electrical discharge is the pumping agent. There is low efficiency and low power output. It operates in CW mode, that is continuous wave mode. You can see a 4-level pumping scheme, E1, E2, E3 and E5. These are the 4-level pumping schemes. And because the lasing action, this maintains the lasing emission and operates the continuous wave mode. So this is a very good laser which helps to have a continuous wave mode laser.